Good day, students. Welcome to part 3 of the New York State Regents exam for Algebra 2 Trig. I'm going to be going over questions 21 to 27 in this installment. I have part 1 and 2 done, so you can just click down here if you want to access part 1 and 2. And then this is part 3, the last part for the multiple choice. Okay, so let's go ahead and continue with question number 21. Alright, question 21 says, a spinner is divided into 8 equal sections. 5 sections are red and 3 are green. If the spinner is spun 3 times, what is the probability that it lands on red exactly twice? So note that it's been spun 3 times, okay? If you're dealing with a spinner, you gotta remember that repetitions are possible. So with a spinner, the probability here is independent, okay? What does it mean to be independent? One spin does not affect the next spin, okay? So the denominators are going to stay constant here. So in this problem, we have 8 sections in all. We have 5 red and 3 green, all right? Since it's evenly split, everything is all equally likely to happen. So if we're going to get red exactly twice after spinning it 3 times, what are my options going to look like? Well, one of the possible outcomes is when I spin it, what if I spin it the first time and I get a red? Spin it the second time, I get a red. And then the next time, I get a green. Okay, so I have exactly 2 reds here. I have red exactly twice. Is this the only possible combination of 2 reds you can get when you spin it 3 times? Absolutely not. What if I got a red first, and then a green, and then a red? This is another possible combination that I can have. Is that it? What if when we spun it first, we got a green, and then a red, and then a red? Okay, these are the possible outcomes that can give you exactly 2 reds when you spin the spinner 3 times. Okay? So now let's work the individual probabilities of each of these cases, and then since we have this, we can get the first combination, or this combination, or that combination. Alright, so let's look at the first case. So for the first case, how many reds do you have in all? You have 5 reds, right? So it's possible outcomes, which is 5, divided by total number of outcomes, which is 8. So that's the probability of getting the first red in the first spin, times, how about the second spin? Since it's independent, and repetition is definitely possible here, how many reds are there after the first spin? After the first spin, there's still 5 reds, so you're going to have 5 over 8, because the spinner doesn't change by the number of times you spin it, alright? So how about green? How many greens are there? There are 3 greens. How many in all? 8. You notice how the denominators stay the same because this is like an independent situation, alright? So or basically means you're going to be adding. Now how about this one? How many reds in all? 5 out of 8. 5 is probability of getting a red in the first spin. Second spin probability of getting a green is total number of greens, which is 3 divided by the total number of sections you have, 8. Sections doesn't change, and then the red again is 5 out of 8 probability, okay? Plus, how about green, red, red? Grr. For green, there are 3 sections for green over the total, 8, times probability of getting a red is 5 out of 8. And then the probability of getting another red is 5 out of 8. Alright, so when I add these 3 probabilities, that should give me the final answer. If you notice, they're exactly the same thing. It's just that the position of the green is moving around. But since multiplication commutes, all these will be exactly the same thing, alright? So when I times the numerator, I'll get 75 over 512 plus 75 over 512 plus 75 over 512. Alright? And then when I add them all up, I'm going to end up with 225 over 512. So you gotta be careful here. Some people do only one combination and then pick this. This is a good distractor. That's wrong. The answer is option 4. Alright, let's move on to question number 2. 22, sorry. It says, what is the range? Now, whenever you think of range, you're thinking about the vertical span. The range is how high does the graph go and how low does it go vertically. Okay, how low and how high, right? That's the vertical span of the graph. That's what the range is. When you talk about domain, is how wide does it go? How far to the left and how far to the right. Okay? This is for domain. Domain is horizontal along the axis. And then the range is vertical along the y's. Alright, so keep that in mind. So in this graph, there are two ways I'll show you how to do this. You can use your calculator to graph this and then determine the range by examination, or I can find the vertex. First thing you want to notice that this function is a positive absolute value function, so it's going to be opening. The opening is up, so this absolute value function opens upwards. All right. If there were a negative here, then it will open down. If I can find the vertex, that will be the low point because that's how low it's going to go. So if I have f of x equals absolute value of x minus 3 plus 2, to find the vertex of this absolute value function, I'll take the opposite of the number next to 3, which is 3, and then whatever number you added on is the y coordinate. Okay? So this is the coordinate of the vertex. So let's see. What will the graph look like? If I want to sketch this graph, I'll go 3 units to the right, 1, 2, 3, and I'll go up 1, 2. Bam. There goes your graph. Since it opens up, it's going to be, absolute value is like a V graph, right? So it's going to open up something like this. The question is asking us for the range. So how low do you think this graph goes? It goes as low as 2, right? Including the 2. And then how high does it go? It goes to infinity, all right? How do I know? Look at the graph. What is the graph doing? The graph goes up forever and up forever. So that's how I know it goes to infinity. So how do you express that using your set notation? The range is basically y such that y is what? Greater than or equal to 2. Alright? So the answer is option 2. So let's say you didn't know how to generate a rough sketch of the absolute value function. Let me show you how to do it with your calculator, alright? So if you have a graphing calculator, I need wait a minute. I need absolute value to generate this, okay? So if you don't know where to find the absolute value, always go to the catalog, which is second function 0. Second function 0 always take you to the catalog. Alright, so I'm going to go second function 0. ABS, that is absolute value. Alright, so I'm going to enter ABS, absolute value of x minus 3. Close that to close off the parentheses, the absolute value bars. Plus 2, enter, sketch your graph. Now, you see how it opens up? This is what the graph looks like, alright? And if I want to find out what the minimum is, I know it's at 3, right? So I can just do a trace. When x is 3, enter y is 2. So there you have it. Or there's also another function there that says calculate minimum, which is 3 right there, option 3. So you go second function trace, go down to option 3. Left bound, you go to the left side of the minimum point, enter. Right bound, you go to the right side of the minimum point, enter, voila. Ooh. Oh, wait, it says guess. Yeah, well, guess means that should the minimum be between these two arrows right here? And just press enter again. Boom, your minimum is 2. Alright, so you can see that that's a low point, as suggested here. What is the high point? It goes up forever. Alright, so that shows that your range is y is greater than or equal to 2. Alright, now moving along to 23, it says which calculator output shows the strongest linear relationship between x and y. So if you want to determine the strength of the linear relationship, all you need to do is look at how close the r is to 1. So let me write a remark for you. The closer r is to 1, the stronger the relationship. Okay? The stronger the relationship. Alright, this closeness I'm talking about is either from the left or from the right. Alright, so don't look at closeness as a as a unidirectional um, concept. It goes from both sides. All right. So the question is, out of these four options, which one is closest to 1? All right. We're looking at the R's. A and B doesn't really count. All right. So let's look at them. So which one is closest to 1? Let's see. If this is 1 right here, well, we're going to be looking at not just R. All these R's are going to be taking the absolute value of all these R's right here. Okay. So we're going to take this one is already positive. That's positive. This one is positive. So for this one right here, R equals -1. I'm going to take the absolute value because we don't really care about the sign. We care about the number, right? So this is going to be 0.8924. So if you look at all these numbers, which one is closest to 1? This is 1 right here, 0.6. Oh boy, 0.6 is far away. Let's see, this is 0.6. 0.83 and 0.86. This will be 0.83 right here. 0.86 is closer to 1, so we can put 0.86 right here. How about 0.89? 0.89 is the closest, right? 0.89. Okay? So this is the closest to 1. Just remember, when you're looking at the R for the relationship, forget about the sign. Okay, just focus on the magnitude of the number. So your answer here is option 4. Alright, let's move on to question 24. It says if log x squared minus log 2a equals log 3a, then log x expressed in terms of log a is equivalent to what? So let's see. Alright, let's work this out. So we have log x squared minus log 2a equals log 3a. So one thing you want to remember is that whenever you're adding logs, what you're doing is you're multiplying the numbers, okay? You're multiplying the numbers, and then when you're subtracting logs, what you're doing is you're dividing the numbers, all right? Keep that in mind, okay? All right, and then exponentiation, if you have exponentiation, that's the same thing as multiplying, all right? So exponent is the same thing as multiplying. All right, now I got it reversed. Multiplying is exponentiating. So when you have a number being multiplied by itself, that's basically the same thing as exponentiation. So if you have the logs being multiplied, is basically exponentiation of the numbers. All right. Okay, so let's take a look at this example right here. I want to get x by itself because that's what the question asks for. It says isolate log x. So to do that, first thing I have to go is log 2a. So what I'll do is I'll add log 2a to both sides. Log 2a. Add log 2a here also. So that's going to leave me with log x squared equals log 3a plus log 2a. So is this going to be log 5a? Absolutely not. Be careful. When you're adding logs, remember you're going to be multiplying the numbers. So log 3a plus log 2a is going to be log of the product of what you're taking the logarithm of. Alright, so this is going to be log x squared equals log 3a times 2a is 6a squared. Okay? Alright, now we're going to take the square root of both sides so that I can get log x nicely isolated. Then I will focus on reducing the right side. Okay, so take the square root of both sides. You're going to end up with log log of x equals now how do you wait a minute, I made a mistake, sorry about this. Alright, I'm not gonna root it because that's not gonna work. So what I'm gonna do is I'm gonna use the properties of logarithm here. So you see this 2 right here? I can move this 2 to the front, right? So this 2 I can move to the front. see this, so I can move it to the front of the log right there. So this, the left side basically becomes 2 log x equals log of 6a squared. Alright, sorry about that. Alright, so let's see. How do we do this? On the right side, I can break this down a little bit, right? So before I do that, let me get rid of this 2. So to get rid of this 2, I can write this as 2 over 1. And I can multiply it by 1/2. So multiply this by 1/2 and multiply this by 1/2 to get rid of the 2 over here. So these 2 cancel out. So you're left with log x equals 1/2 log 6a squared. Okay? So does this match with any of the answers that we have? If we go up and look. No. We need to do some more work so that we can match it with an answer. So to do this, all we just have to do, we just have to break this one up, alright? So this is log base x of 1/2 of log 6 times a squared. You see that? When you're multiplying numbers, I said it earlier, when you're multiplying numbers, you're adding the logarithms, okay? So we're going to convert that into logarithms. So since we're multiplying these 2 numbers, it's the same thing as log x, bringing down the left side, 1/2 of log 6, put this in parentheses, log 6 plus log a squared. Okay? Log 6 plus log a squared. You notice how I converted the multiplication of the 2 numbers to the sum of logarithms? That's how the rule works, alright? So next thing we're going to do, we're going to use the power rule for logarithms. So these 2 can revert to the front, just as I did over here. Because there's this rule, if you have log a to the n, it's the same thing as n, it's the same thing as n log a. Alright? Same thing as n log a. Like that. Okay, because when you multiply repeatedly, if you multiply this n times, it's the same thing as though you were adding it n times, so you're going to have n log a right here. So this so advancing here, we're going to have log x equals 1/2 of log 6, and then when the 2 comes to the front, it's going to be plus 2 log a. Bam, like that. Alright? To finish this off, we just distribute 1/2 to everything. Distribute 1/2 to this logarithm and then to that logarithm. It's going to be multiplied by the coefficient. So we're going to have log x equals 1/2 of log 6 plus 1/2 times 2 log a. Alright, so these 2 cancel out. So you're going to have log x equals 1/2 log 6 plus log a. And that's your final answer. So the option, if you scroll up, is option 2. Okay, so the answer is option 2. Alright, moving along. Let's take a look at this one. It says which of this function is 1-to-1? A function that's 1-to-1 has to pass. Let me write it all in complete sentences. So a 1-to-1 function must pass the vertical and horizontal line tests. Okay, must pass the vertical line test. Okay, horizontal line test is unnecessary since it's the function already passed. If something is a function, it already passes the horizontal line test. So a 1-to-1 function must pass the horizontal line test. Okay, so it must pass the horizontal line test. What on earth is a horizontal line test? It just means that if you draw the graph, if a horizontal line passes more than once, then it's not function. It's not 1-to-1. If it passes exactly once, then it's a one-to-one function, alright? So what on earth am I talking about? Well, let's take a look at some examples. Number one, f of x equals absolute value of x. You can draw the graph with your calculator, but I'm going to draw it by hand. This is your v function, right? What does a horizontal line do here? Does it cut more than once? Is there a horizontal line that cuts this graph more than once? Of course, multiple places, right? If I draw a horizontal line right here, it cuts here, 1, and it cuts here, 2. So since it cuts more than 1, this function is not 1 to 1. Okay, that's 1 to 1. So you see what the horizontal line test means now? Now let's take a look at the second function, number 2, f of x equals 2 to the x. Remember, if you forget how these graphs look, you can just use your graphing calculator to sketch them. So this is an exponential function. Looks something like this. Is there a horizontal line that cuts this graph more than once? Absolutely not. All the horizontal lines cut this graph at exactly one point at every point. Alright? So this graph passes and passes. So it is 1 to 1. Alright, so that's the answer. The answer is option 2. Okay, let's try option 3 and 4 just for practice. Option 3, we have f of x equals x squared. What does your parent quadratic graph look like? The parent quadratic graph is just like the u, right? So there goes my y-axis and my x-axis. This is something like this. Remember, if you don't remember how these graphs look, you can always graph it in your calculator, right? So y equals x squared. Is there a horizontal line that cuts this graph more than once? Of course, almost everywhere, right? If I draw a horizontal line right there, cuts once and twice. So that tells you that x squared is not 1 to 1. Right? Last but not the least was sine x. Remember what your sine x function looks like? Well, if you don't, you might have to bring out your calculator and sketch it. But your sine x function is like your sine wave, is like the s that keeps going on and on forever. So option 4, you have the sine curve. It goes like this, and then it keeps going on and on and on. It follows that pattern forever. You know what it looks like. Anyway, is there a horizontal line that cuts this graph more than once? Absolutely. In fact, it cuts multiple times. If I draw a horizontal line right here, what do we have? We have 4 intersections. But actually, in reality, we have infinite intersections because this pattern repeats itself. So 1, 2, 3, 4, and it goes on and on. So this is like definitely not 1 to 1. So you can basically see why our answer is option 2, because that's the only one that has horizontal lines intersecting the entire graph at exactly 1 point. Alright, so the answer is 2. Okay, moving on to number 26. It says if p varies inversely with q and p is 10 when q is 3 over 2, what is the value of p when q is 3 over 5? So inverse variation is simply as follows. So if p varies inversely with q, that means p, varies inversely with q, 1 over q. So that basically means that in order for there to be an equation, there has to be a constant introduced. So that means p equals some constant k over q. Alright? So I can simplify the equation and multiply both sides by q. Multiply this by q, multiply that by q. So I have pq equals k. So basically this inverse variation tells me that p times q is always equal to a constant regardless. Alright? So basically if I have p1 q1 is going to be equal to p2 q2. It goes on and on. You have a formula like this in chemistry. Pressure and volume. It's an inverse relationship. Anyway, so P times Q is always going to be a constant, regardless of what P or Q is, alright? So using that, let's find out if K is a constant. K is a constant. So let's find out what the constant is using the first piece of the question that we have, and then we can be able to determine what P is using the second value of Q, alright? So if PQ is always constant, then we know that if P is 10 and Q is 3 over 2, then the constant K is going to be given by the product of these two numbers, all right? So if I times this, you get I have 30 over 2 equals k. 30 over 2 is 15. So the constant of inverse variation here is 15, all right? So is that our answer? Absolutely not. Well, we have a new q here. We have to find out what p is. So since I know pq is k, I have a new q, so I have to find my new p. So I'm going to have p times my new q, which is 3 over 5, equals k. k is 15, right? So if I multiply this out, I'll have 3 over 5p equals 15. So how do I get p by itself? I just simply multiply both sides by 5 over 3, which is the reciprocal of 3 over 5. So times this by 5 over 3 also. Alright? So this cancels out with that, this cancels out with that. And then we have p equals 75 over 3, which simplifies into 25. So your answer is 1. Alright? So don't forget, inverse variation is something like this: p equals k over q, or p times q equals k. Alright, now let's move on to the last question. Question number 27. It says, which equation is graphed in the diagram below? So the question is this a positive cosine or a negative cosine? If it's negative, we eliminate these two. If it's positive, we eliminate these two, okay? So remember what your cosine graph looks like, right? It's like a cup. So cosine graph is something like this. The cup opens in this direction and it goes on and on forever. But if you look at this graph right here, it's upside down. So what does that tell you? That tells you that this is going to be negative cosine. So I can scrap out this too. Alright? Just to verify, you can fire up your calculators, and then let me show you what cosine looks like. So this is cosine x graph. See what it looks like? Let's zoom in into the Trig window so you can see better. So zooming using Trig, you see what the cosine looks like, right? Does that look like this? Absolutely not. How about we insert a negative symbol there and graph it again? You see, this is more consistent with what we have right here, alright? So you start from a minimum, your cosine is negative, but positive cosine starts from the maximum, alright? So this is definitely a negative cosine function, but it has shifts in it, alright? So where is the center of this? That's one way of figuring out what the graph is going to look like. All right, so where's the center of the graph? We're going from 2 all the way up to 8. Okay, so the minimum is at 2 and the maximum is at 8. So where is the center going to be located at? Well, let's see. Or another way we can figure this out. Well, we eliminated these two. There's another way we can figure out what the center is of the shift. So we can use the period to figure it out, but we can also use the center to figure it out. So let's do it both ways. So we know that it's either this or this. So the question is the center of this graph shifted 8 units up or 5 units up? Well, that's easy for yours to determine, right? This is the maximum. The maximum is 8. The minimum is 2. So where on earth is the center? It's somewhere is the average of 8 and 2, right? What is the average? If you average 8 and 2, what do you get? You're going to do, you simply do 8 plus 2 over 2. 10 over 2 is 5. So this is actually, the center of the graph has been shifted up 5 units, alright? Positive 5. So that automatically tells you that the answer is 4. Another way you can do it is the period of this graph. If you take a look at this graph, what is the period though? The period of this graph can tell me whether my answer is option 3 or option 4. So you remember how to find the period of trig functions? Whatever the coefficient of whatever comes after cosine, that's b, and that's basically what you use, right? Because you know the formula for cosine function is y equals a for the amplitude cosine bx plus c, right? So if you take a look at this, to find my period is basically 2 pi divided by b, right? 2 pi over b. If you look at this graph from minimum to minimum, the period for this graph is 30. Period is 30 because you're going from from minimum to minimum, and it's 30 units long. So which of these will give me a period of 30? So for this option right here, b is pi over 30. And then for this option 4b is pi over 15. How on earth did I know? Whatever the coefficient of x is, that's what b is, right? This formulation right here, whatever is in front of x, that's basically what b is. So I'm going to do 2 pi over b with these two candidates, see which one gives me 30. Alright, if I do the first one, I go 2 pi over pi over 30. What is that? You multiply the top by the reciprocal of the bottom, which is 30 over pi. And then you're going to get the pi's cancel out 60. Is that the period? Is the period of this graph 60? Absolutely not. Let's try option 4. We're going to go 2 pi divided by pi over 15. If you drop change flip, you're going to have 2 pi times the reciprocal of the denominator, 15 over pi. Pi's cancel out. 2 times 15 is 30. Voila. This is what we want. Okay? So you can either use the center, P5, to determine that this is the answer, or you can use the fact that the period is 30 to figure this out. Okay? So 2 ways of doing this problem. Alright, thanks so much for watching this video. Please subscribe to my videos to help support the production of more videos. If you like this video, please click like down here. If you have issues with the video, just write down some comments or send me an email. I'll be glad to address it where applicable. My channel, my clips can be found on mathgotserved.com. Thanks again and have a wonderful day.